Was it the 2024 unit 1 paper or something?
Yeah, just maybe yeah, just 2024 October.
Are you sure?
One, no, no, May, June.
Sure, 100% sure. Hold on.
My one,
Let
my
me.
one doesn't say if it's May or June, but it's 2024 Unit 1.
2024 unit 1. Just tell me the code, will you? In the paper? Like in on the bottom, there's a code. Like P6 something. P65. What's the code? Is the first question about an engine used to remove water from a mine? Is that the one, Rumika? Is that the question?
So the answer is right in the middle.
Huh.
My book is
So 2020, let me put the recording, hold on. I'm sorry. Okay. Alright, okay. So we were supposed to discuss 2021 May June Unit 2 paper and 2025 May June Unit 1 paper. So before that, first of all, I'm gonna send a question to the group. Okay, you guys have your phones, right? Yeah. Rumika, are you able to access the group, the WhatsApp group?
yes, sir.
Yeah. So I'm gonna send a question now. This is from a past paper, the 2025 Jan paper. Okay. I'm gonna send you a question. It's about energy transfer. It's a simple question. Okay. So after this, there's one more question. It's about density and upthrust. So I'm gonna first of all send this question to you all. I want you guys to complete this question and I'm gonna time it, okay? I'm gonna give you a certain time period to do this question. You have to complete the question within that given time period, okay? I'm gonna time it, so just hold on a sec. Mm, this is the first part, and then now I'm sending the second part. This question is out of 7 marks, okay? So I'm gonna give you all of you have received the question. All of you must have received the question by now. I'm gonna give you all 7 minutes. Okay, I'm gonna give you all 7 minutes. See, 7 minutes. Look at the camera. See, 7 minutes. I'm gonna give you all 7 minutes. You have to get those 2 questions done within 7 minutes. No need to copy the question or anything. Just take a rough sheet of paper, take a pen, start writing answers. Okay, on a three. Rumika, you are ready, right? Ready, neither? Right? Okay, I'm gonna start. Three, two, one, start. Okay, I'll let you guys know when the time goes off. Those who are watching the recording also, I have put the timer and I'm gonna keep the recording switched on. I'm not gonna pause the recording or cut any part of the recording. Uh, you have to finish the paper within the given time limit. I have sent the question to the group. Okay, so it is the question that I have sent at 7:08 p.m. Right? Okay, quickly start. You have 6.5 minutes exactly. So if you all have any questions, let me know. Questions in the sense not related to the question that I've sent. You can't ask issues about the question that I've sent. If you don't know the answer, you can just keep on trying. Yeah. But if you really don't know how to get the answer for part A, skip and go to part B. We'll see. You have 6 minutes left. Sine. So 4.5 minutes remaining. You've got 4.5 minutes left. So 2.5 minutes remaining, guys. 2.5 minutes. Okay, I finished. Finished. All right. Okay. Alright, alright, let's wait. So, Romika, if you are done, raise your hands. Raise your hand. Okay. You should be done with both parts. Alright, three of you are also finished, no? It's actually pretty good because there's like 1 more minute remaining. Okay? Okay, Rumika, you can put on your hand. Okay, so all of you are done now. That's good. So let's discuss and see whether you got the questions correct, the answers correct. Let's see. What was this question about? Um, so they say the Crochan hydroelectric power station in Scotland is built inside a mountain. Okay, right. Where are they getting with this? So they are saying water from a lake near the top of the mountain flows through straight pipes to a generator. The pipes have a length of 350 meters and are inclined at an angle of 55 degrees to the horizontal, as shown. Okay, right. Then they are saying the gravitational potential energy of the water is used to generate electrical power. In 1 minute, each pipe transfers this much of water to the generator. Density of water in the lake is 1100. Show that the power transferred by the water in each pipe is about 88 megawatts. Okay, so those who have done this question before, can you all raise your hands? Kal तीन question before. No. What about Rumika? Rumika, have you done this question before?
I can't remember doing it, but
All right. It feels familiar, no?
just ask.
Yeah. Okay. 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 Okay.
Yeah.
Yes. Right. So basically, for a question like this, first of all, you have to calculate how much is the GPE, how much is the gravitational potential energy. So how do we do that? To calculate GPE, we need the height. So it's actually a triangle if you think about it. They say this is how much? They say this end is 350 meters. So 350 meters at an angle 55 degrees. At an angle 55 degrees, let me just zoom this in, otherwise, so watching the recording won't be able to see it. Yes. So then we can find the height using 350 sine 55. We build an expression for the height. Then what should we do? They are saying in 1 minute each pipe transfers 1700 cubic meters of water to the generator. Density of water in the lake is 1100. They have given us density, they have given us volume, so we should find mass, no? We need mass to get weight, no? So then volume times density is equal to mass. So 1700 times 1100, that is the mass of water transferred per minute. Then after finding mass, what is the mass that you got? What is the mass that you got? What is it? 1817 10 to the power 3. You are saying, Yaman, you are saying that much, no? What about you, Rumika? Is it correct? Is it 1.87 in 10 to the power 6?
I can divide by 60 altogether, so I don't know what the
What did you do, Rumika? Can you send me what you have done?
same thing.
Alright, send me, will you? So then, next, you get the mass like that. Yeah, if you say so, you get the mass like that. Then height 350. What is 350 sine 55? Here 287, no? Yes, 287 meters. Then next, what should we do? We should calculate mgh. We can calculate the gravitational potential energy, right? So then gravitational potential energy is equal to what? 1.87 10 to the power 6, 9.81 times 287. What is the answer you are getting? You should be getting 5.26 times 10 to the power 9 joules, right? 5.26 10 to the power 9 joules. They are saying this is for 1 minute. You are supposed to find the power. So from units you can get what is power. Why? We know that 1 watt is equal to 1 joule per second. So energy, work done, divided by time in seconds. 5.26 10 to the power 9 divided by 60. Sorry. I'm sorry. What are they saying here? In 1 hour, 1 minute. In 1 minute, right, guys? They are saying 1 minute. Yes. So you should divide by 60. I'm correct. Then you'll get the answer. What is the answer you got? Key denne. 87. 87.7. 87.7 in 10 to the power 6 watts. That should be your answer. Is it clear? That should be the answer that you must have gotten. Rumika, is it clear? Is your answer correct? Let me just check. No. Yes. 87.8 megawatts. Correct. That is the answer. Yeah. So you instead of 10 to the power 6, you can write this as megawatts. Correct. And how have you taken the answer? So basically, you have taken what is H? Yeah. Then you have taken mgh. How have you taken the mass? How do you take the mass?
So I should do mass per in time.
Mass per, you took M over T. Right. You've taken M over T. Right, okay, then it's fine. Why? You have just divided M, this value right here, where we go used to get mass. So what he has done is he has divided M by T, and then straight away you have calculated the rate of flow of water, right? So that means volume per unit time. So therefore he has to put V over T here. Since he has to put V over T, M over T must be put in order to balance left and right hand side. So then, yeah, that method also can be used. That is a little bit more sensible, no? In a given time period, yeah, it is. Right. So basically, that is it. Part B. In part B, it's a very easy question. Part B, they have asked water travels from the lake to the generator through four identical pipes. As water moves through the four pipes to the generator, total power wasted. Now remember, wasted power is 257 megawatts. It's a good thing that you converted part A answer to megawatts. So we know that now useful power is, this is what, yeah, this is the useful power 87.7. Wasted is 256. So all we need to do is multiply our useful power. This is from one pipe. We found out the answer 87.7 megawatts. That is from one pipe. So for part B, guys, 87.7 megawatts must be multiplied by 4, because this is for one pipe. For four pipes, how much is the useful output then? 87.7 times 4. That is the total input. Sorry, not the useful. This is the total. This is the total input. Total energy input. What is the wasted energy? Wasted energy they have said as 257 megawatts. So how do we calculate efficiency? You should know efficiency is equal to useful energy output divided by total energy in. So to calculate the total energy, we already know it, 87.7 times 10 to the power 4. That should be divided, okay, wasted energy, useful, total energy minus wasted energy is our useful energy. This was total energy, that minus wasted energy is our useful energy. So then you subtract them, you can calculate the useful energy by subtracting wasted energy from total energy, and then you can get the answer for useful power output as how much on 94.8 megawatts. And yeah, that's what Rumika has taken as well. He has straight away subtracted, put the answer in the calculator. Yes, right. So then that should be divided by total power in. You get the efficiency as 27.1% if you multiply the final answer by 100%. I hope you know the equation for efficiency. If you don't, and you are watching the recording and you really don't know the answer, just type efficiency equation on Google, you'll get the equation. Or you can go to the last page of your book, your paper book, most probably. So in the exam paper, usually they give it in the last page. However, in your paper book, they'll give it in the last page, not in each paper. In exam, in each paper, you get the equation sheet. In that also, efficiency equation is there, guys. Okay, right. Good job on that. I underestimated you guys. I gave you too much time because this was the first question that I was giving. I told you, right? I'll give January and what do you call January and October, November papers. I told you I'll give in class. I'll be discussing all the May, June papers, right? Yes. So the next paper that I'm gonna be doing, the next question, okay? I'm gonna send it. Don't start the question yet, till I say so. Don't start. Okay, let me find the question. Okay, okay. This is really easy, yeah. This is like really easy. It's a moments question, guys. So moments question, I'm gonna send it to you all. Just wait till I say how much time is given. Now. Okay. So this question, those who are watching the recording, listen closely. This question I am sending at 7:26. Okay, this is the question I am sending at 7:26. Okay, right. Okay, so here you are given 8 marks again. I'm gonna give you 5 minutes. I'm gonna put the timer. Hold on. I'm gonna give you 5 minutes. Okay. Usually I would have given you 8 minutes, but then since you were so good in the previous paper, I'm gonna give you 5 minutes. Now don't disappoint me. Huh? See, 5 minutes. Oh no, I'm gonna start. Shall I start? Take out the paper first of all. Right, Rumika, you got the paper, right? Hello, Rumika, are you ready? Yes, neither. Okay, I'm gonna start. I'm gonna start. 3, 2, 1. Okay, start the question. Right, and I'm gonna let these questions, let the recording be as it is. I'm not gonna pause it. So those who are watching the recording can also attempt this then and there. Um, if you are done, let me know. Physical students, online student, Rumika, you raise your hand. Okay, 2 more minutes left.
Says the mass of the rice given because there's something that's
Mass of the rice. Let me check.
yeah.
Yeah, let me check. Let me check. Uh, dish moved horizontally. No, 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 no. You are supposed to deduce. Mass of rice is not given. It's not covering anything. Let me check the image. Yeah, it's not covering anything. Mass of rice is not given. See, that's the difference between deduction. I mean, you have to do a simple calculation here and show them that how many, like this dish.
Labor say,
Sorry?
what is the labor that I
A label in the sense that WPH, that thing.
no no that what does that say?
What do you mean?
Did I put that's point? Did it say one portion of something or is it
No. Here's the thing. You have to calculate how many portions are there in the rice. Okay? How many portions of rice is there in this beam or something. And then you have to deduce that whether the dish contains 3 portions or more portions of rice. Is it clear? So they are asking the dish is moved along this thing and rice is added until it is in equilibrium. So you have to say how many portions of rice are there. You're not given the mass. Actually, it's time, You're not done. None of you are done, no? I think I went a little bit too overboard with this. You should actually have, like, see, the 6 mark question. You should actually have some time to think and, like, you'll probably get in the exam, in a realistic situation, you would have gotten around 8 minutes. But since you're not yet completed, I'll give you like two. Do you need more time? The time, Ashiru, you want more time? Okay, I'll just in case, I'll just give you like 1 or 2 more minutes. Okay, Rumika. So I'm gonna explain. Put in. I'll just let you try. I'm gonna give a hint. So basically, they say the dish is moved along the beam, so that horizontal distance is this much. Rice is added until it's balanced in equilibrium. Deduce whether the rice contains 3 portions of rice. You should include a calculation of the weight of 1 portion of rice. Okay, so here's the thing. Forget about 3 portions of rice, first of all. You must try to calculate what is the weight. What is the weight of this whole portion of rice? You must use the principle of moments here. So you have to understand. So this is the hint. Listen closely. You have to understand total weight. Okay, total weight should be equal to weight of rice plus weight of the dish. Okay, weight of rice plus weight of the dish. So that's the hint. So I think you are already given what's the weight of the dish. If you can find total weight, subtract the weight of the dish, you'll be able to find the weight of total amount of rice. No, I think they have said also in the question that the dish is able to hold, I think, like 1 portion of rice only or something like that. I don't know. I did this question uh, around this Jan with no, not Jan, last year December, with some students who were doing the exam in 2026 Jan actually. So I can't remember exactly. I'm just going over the question. I'll have to look at the question when I'm discussing this with you all. Okay, just give it a small try. I'm gonna give you 2 minutes more. Okay, Romika, just give it a small try. So here's the thing. If you tried and now you are fed up and you don't know how to get the answer, so raise your hands. Physical students, you can raise them once and put them down. Don't raise both of your hands. Rumika, you also. If you're like fed up and you don't know how to get the answer, then raise your hands. If you got the answer or you thought you have gotten the answer, don't raise your hands. Okay? Right, we'll see. Alright, okay. You guys, this and you see. Oh, this thing. Alright, okay. Everybody's using hands. Make it Amaruda. Is this question that hard? Alright, we'll discuss. Okay. Uh, question number 16. Part A. Uh, 16 part A. There's no calculation, no? State conditions needed for an object to be in equilibrium. So basically, what are the conditions? One is resultant forces must be zero. Then, what is the second point? Resultant moment about any point must also be zero. So resultant force zero, sigma r zero, and resultant moments also zero. So actually, in maths we use G, no? G equals zero, moments equals zero. Don't write it like that. Here, write it in words. Okay, right. Now moving on to part 2. Abhi balun mein part A if they have said something, a balance beam, a dish is hung, measure. Hi, see, a dish is hung from the beam, and the balance is used to measure a fixed portion of rice. See, now read this part very carefully. When the dish contains one portion of rice, the balance is in equilibrium. They have given this balance. Mein. See, at this balance, when the balance is in this manner, there is only one portion of rice. Now, get that into your head. They have given the weight of the beam, weight of the empty dish. What is the weight of the beam? They have given the point where the weight of the beam is also acting. See, center of gravity of the beam means the point in which the weight of the beam is acting. Ne? So, can't you find, if they say this is in equilibrium as well, can't you find what is the mass of one portion of rice, guys? Can't you do that? I mean, see, it's very easy. First of all, you have to try and find the mass of one portion of rice. This is not in the marking scheme. The marking scheme has not followed this method. It has followed a little bit complex method. This string has not moved now. Why? Even though we move the string or not, the mass of one portion of rice remains the same. It does not change. So what is the weight of the beam? 3.1 newtons. 3.1 newtons. So this is, I'll just do a small drawing as well just in case. Otherwise, those who are watching the recording, if they get confused, you never know. No? They won't have any method of resolving this. Where is my other color pen? So this is the dish. Here's the one portion of rice. Made in the center of gravity of the beam. So a weight of 3.1 newtons is acting down like this. Mass of the dish plus mass of rice, both are same. Okay, so I'm gonna take it as m. Yeah, let's take it as not as m. I'll take it commonly as f. Then they have said the distance here is 25 cm. This is 8 cm. I know it does not look proportional, but then just take it as it is, Billy. Can you see? If I were to apply the principle of moments and they are saying this is in equilibrium, 3.1 times 8 equals f times 25. Ne? So what is f? Rumika, can you tell me what is f? Can you see this?
That's the weight of the dish and the.
Yeah, no, I mean find f and tell me what is f. Use your calculator. Zero point 992. Okay, now hold on. 0.992, that is f. So they have given weight of the dish as 0.64. So what is mass of one portion of rice? What is the 0.35? 35 kilograms, no? Is it kilograms? Let me just zoom out. Not kilograms, newtons. Sorry, my bad. Uh, 0.35 newtons. Yes. So, then what happens? Then we need to look at part B now. What are they saying? The dish is moved along the beam so that horizontal distance from the string to the dish is 7 centimeters. So they have moved this from here to 7 centimeters. I'm gonna do a new drawing then. See, I'm gonna do it in a dotted line. I'm gonna draw it in a dotted line. They have moved it from here to here, ne? See? So this is actually 7 cm, isn't it? 7 centimeters. This is now 7 centimeters. This is 8 centimeters. This is kept at it was. We can't change the center of gravity no anyway. Dish was moved towards the center of gravity. Right now they are saying rise is added until the balance is in equilibrium. So what do? We find what is the new equilibrium. Okay, so this is for the old one. This is the new equilibrium. I'm gonna put new here. And then write 3.1 times 8. Can you understand? It is again equal to 7. So let's imagine now this weight as A. A looks bad, no? A looks bad. A is not good as a force. Let's take it as M, guys. Okay? Let's take it as M. No, M also looks bad. Api gamu make a hold on. What can we take this as? Let's take it as S. S is better. Okay? I'm gonna take the force as S. So 7 times S. Okay? I don't know. It's we can't take it as F again, no, because these two are different. So then again 3.1 times 8 is 2.48, no? Is it? Is it 2.48? 24.8, isn't it? Yes, it is 24.8. So that is 24.8 divided by 7. That is what the S is. Now remember, that is the mass of the dish plus number of portions of rice. Okay. So calculate S and tell me what is S. What is S? What is S, guys? What is this S? So we have to do is divide 24.8 by 7. We are getting 3.54. We are getting 3.54. 54 or 55. 3.54 newtons. Is it newtons? Yes. We know that the mass of the dish, okay, mass of the dish is 0.64. So what do? We subtract 0.64. Okay, we subtract 0.64 from this 3.54. Then what are we getting? We are getting mass of all the rice portions. So what is the answer then? 2.90, no? So we know mass of one rice portion to be 0.35. So how do we calculate number of rice portions now? We divide 2.90 by 0.35. You should get an answer as 8 point something. Is it 8 point something? Yes. You should get an answer as 8.350, 70, 280. You should get an answer 8.2 something. 8.2 portions of rice. Is it clear? Is it clear, Omika? For you, is it clear? It is clear, right? So then, can you understand? They are saying deduce whether this has 3 portions of rice. So what should you say there? You should say no, there are 8.2 portions of rice. So it is false. Now, can you understand? Even though I said we are like I asked you to focus more on May June papers, there are questions. We can learn stuff in other Jan papers and October papers as well. See, a question like this has not been asked in May June papers, like in this specific manner. This deduce this and that. So these questions are important. Why? They can ask this in May June since they have not included these kinds of questions in May June papers before. That is the reason. Okay, right. So copy this down first of all. That question is over then. 6 marks. Okay, 6 marks not for an explanation, for a calculation. So the previous question I gave you, they were giving 5 marks, not for an explanation, for calculations. Huh? Okay, right. Okay, next I'm gonna send you another six marker question. Okay, I'm gonna send you another 6 mark question. First of all, finish it. It is a part. It is a section of a main question. I'm not gonna send you the whole question. I'm just gonna send you the 6 marker question part. It's actually an explanation question. Okay, raise your hands if you're done with copying this. Right. Okay, Romiki is done. You're still writing. All right. Okay. Give us 2 more minutes. Oh, no, 1 minute is enough. Try to write it in 1 minute. We have a lot of questions to do, man. That's why. It's very cold, no? That's because I put the swing down. I'm gonna put it up. Should be fine now. You know, guys, actually, funny thing happened. We had this alms giving, okay, and like there was a lot of food, okay. You won't believe, like there were like a number of food. I couldn't even count. There were like 40 or 32 kinds of food, and then we had like a lot of desserts, okay. We catered them from some hotel, not me, my parents, I think. There were like a plenty of desserts, and they had this very cool stuff. I ate a lot of it. Like I didn't eat in the morning. I straight away ate lunch on there. I couldn't even eat dinner after that. And then after that I got sick. Ah no, after that I actually went out. I went to my aunt came. So she lives in Kurunagala. She's also like a huge English teacher there. She came from Kurunagala, so she came to the alms giving actually. Then I just went out with my aunt and my cousins and everyone after our alms giving, and then I went to Gold Face. We went to OGF, we watched a movie. I again drank this cold stuff there, and then right after that, I got sick and I had like a very high fever, you know. I don't know what happened. I must have eaten a lot, like very cold food types. It's been like 3 days now, and I still am taking antibiotics. Okay, I'm sorry. Right, I'm gonna send the question. I hope you all done, nah? Done? Eh? Yes. Okay, so I'm gonna give you. I'm gonna be good here. Okay, I'm gonna be sensible here. I'm gonna give you guys 6 minutes. To get this question done. Okay, you have 6 minutes. Remember, you have 6 minutes. Get this question. Ah, no, no. Yeah, I don't think you are able to do this question without the first part. You can do though, but okay, whatever. I'll just give the first part as well. Question number 18. So this is the first part. You have to do a vector diagram. We have to draw a vector diagram. It's a scale vector diagram. You have to draw it to a scale, and Rumika, you have to send me a picture. Okay. Then that is part A. Don't start yet. Next, what we have is part B. So basically, in part B, B is the 6 marker question. So as you can see, A is a 5 marker question. Just for a drawing. I'm gonna give you all. I'm gonna be sensible. I'll give you 10 minutes. Ready there? No enough. But remember, you have to write 6 points there for part B. It doesn't need to be 6 sentences. I'm gonna give you 10 minutes. I'm gonna put the timer now. So I want you all to start doing the question. Hurry. So those who are watching the recording as well, try to do this question within 10 minutes. So I've sent the question to the group at 7:52 p.m. That is the question. See, 9:51. Start doing the paper. And so, Rumik, if you're done, you can raise your hands. Others, I'm here. No, you can tell me that you're done. Okay, right. Okay, are you done, Romika?
So I'm writing for.
All right, okay, take your time. You have 4 minutes. You guys have 5 minutes, huh? 4.5. Time's up, guys. The time is up. Are you all done? No. What about you, Shromika? Are you done? You are finished?
Yeah, I completely like 5 seconds ago.
Ah, that's actually good. Okay, okay. Let's just wait one more minute. And they are also finished. Let me just check what they're saying in this paper. And while they're doing that, can you just send me your vector diagram? Hmm. Okay, Rumika, I was saying to you, send me your answer. This answer in the sense, your diagram, and if possible, send me the description as well. Na? It's easier then. Straight away say that it's correct or wrong. Mm, 11 marks. Hmm. Okay, 43. Yes. Yeah. This diagram is correct. This is correct. Directions are correct. Resultant force 36 newtons. Correct. Yeah. Okay, Rumiki, your part A is correct. Let me check others. So yeah, you can give me part A. Just show me part A. What's the answer? Yeah, that is correct. Either 37. Yes, correct. You've gotten 35. Yeah, correct. So as long as your answer is between 34 and 38, they have awarded marks for resultant force. You're gonna lazy ne? The question is easy, right? Yeah. No need to stand up, okay? You can sit down and mute me. Hurry. Correct, correct, correct. Yes. Part A is correct as far as I'm concerned. So for part B, I really check one by one. I'm just gonna explain. So if you have these points, give yourselves marked. I'll just go over the papers, huh? Once I get a chance, once I come through, I'll just go over the papers. මෙන්න මේ points ටික ලියලා තියෙනවද කියලා බලන්න පොඩ්ඩක් for part B. So you are finished, ne? Right. So let's see what they are saying in part B. In part B, basically, they are saying a crane on a ship can lift a submarine out of the sea as shown. Okay. Then the submarine is initially completely underwater and at rest just below the surface. So it's below the surface, remember. Then they are saying a cable from the crane uh, is attached to the submarine. So the cable is vertical. Crane pulls on the cable, the submarine moves vertically towards vertically upwards. Vertically upwards at a constant speed until the whole submarine is out of water. Okay. It's moving upwards with constant speed now. Right? So this says something about tension. Explain how the right, see? That's what they're asking. Explain how the tension in the cable changes as the submarine moves from below the surface to being completely out of water. You should assume the drag force on the submarine is negligible. Right. So here, tell me what should we do? First of all, you must say the resultant force. Okay. Initially, what happens? So you should start with the initial scenario always. I've told you before in questions like this, they have given some facts in the question itself. So you must take the most advantage that you can out of it, out of the facts they have already given, especially in these star marked questions. So if you didn't notice, this is a star marked question. Okay, so here when answering these questions, always start from the question, start from what they are saying in the question. So in the question they are saying initially this is at rest under the water. So when it is underwater, tell me, is there a resultant force? No. So you can say resultant force on the submarine initially is zero. Then when at that position, can you understand? Still it is being attached with that rope, right? With that, what have they said there? Uh, with that cable, yes, it is still attached to that cable. So you should be able to understand at that point when it was sunk fully underwater, the tension is equal to the weight minus the upthrust, right? So you should understand when we submerge a liquid, there's always an upthrust acting on it. Archimedes principle. So for the second point, you can say the tension of the cable initially will be equal to weight minus upthrust. Why? Because they are asking the variation of tension from initial to when it was being lifted. So next what happens? Now the submarine is being lifted. So you can say as it leaves water, what happens to the weight? What happens to upthrust? Upthrust decreases. Then weight remains same. As upthrust decreases, what will happen to tension of the cable? It will increase. If you say that elaborately, you'll get like 2 more marks. So 4 marks overall. Then what's the fifth mark for? You must say when it's being lifted gradually, the tension of the cable will gradually increase. Finally, you can say when the submarine is out of water, when the submarine is completely out of water, the tension will be equal to what? The weight of the submarine. It's very easy. It's a very easy question. Okay, so I'm gonna check your answers. Let's see Rumika's answer. Force plus upthrust. Alright, okay, equals to 8. That is correct. Resultant force is 0. There is no acceleration. What? No, 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 no. See, Rumika, you are wrong here. See, volume of water displaced does not increase. Volume of water displaced decreases as it moves up. Volume of water displaced means upthrust basically. You have written decreases and cut it and then written increases again. So upthrust decreases mean? Can't you understand? Did you thought this was being pushed inside? Even if it was pushed inside, the upthrust remained same since it was completely submerged. What were you saying? What were you saying?
I thought the volume of water space decreased because, like, it will.
Yeah, volume of water displaced decreases. You are correct. It decreases. So what I have written here, you have said it increases. So upthrust increases while weight is constant. Tension decreases when the submarine is out of no mean tension increases. So you actually only get 2 marks here out of 6. Okay. Sorry. Let's read others. Did you understand where you got wrong, Rumika? Yeah. Yes. Yes. There is the point where you got wrong was switching from decreasing to increasing again. Hurry. Weight equals upthrust plus tension, yes, and then no resultant force. Okay, 2 marks. Then um, cable increases, yes. Upthrust decreases, yes. Tension increases, ne? Hurry, hurry, yes. Okay, you're so correct. No again. Me, මොකද මේ? You haven't written no. Why? You didn't have time. Okay, complete now. Complete now. Correct. හරි නේද? Thrust increases. Again, see, upthrust does not increase. What is this? Upthrust doesn't increase. Upthrust decreases when moving down. හදාගන්න එතන. You also get 2 marks. මේකට you haven't written what happens initially. You haven't written what happens initially. So you get only 4 marks there. You have to start from the beginning always. Remember that. Yeah, correct. Full marks. You get full marks. Okay, Sandali. Right. Okay. So that's it. That's it. So even in this diagram that we have written, so I show that some of you have written a diagram like this, drawn a diagram like this, mark tension upwards, and then upthrust also upwards, weight downwards, right? So here what happens is, yes, you are correct, weight equals upthrust plus tension. So we are looking for tension, so tension equals weight minus upthrust. When we are being taken out of water, this upthrust must decrease. If you think like that here, you will see that tension should increase. But can you you will see that tension should increase, but you have to remember weight remains constant in both scenarios. If you think like that, only tension increase. Otherwise you might think tension will also decrease, because weight will also decrease, you might think. If you have written the equation in this manner, make sure in both ways, no matter what you have written, weight remains constant always. That is the reason, as we are moving out, upthrust decreases, because the amount of liquid displaced is going to decrease while it is being pulled up. Therefore tension is going to increase. Okay, right. Okay, so now I'm going to send you another question. So these questions are not from the same paper, okay? Some questions are, some are not. Let me just find a good paper for you. So actually this is the 2025 October paper, guys. Unit 1, I think we've done enough. Let's move on to Unit 2. Yeah, let's move on to Unit 2, okay? I'm going to move on to Unit 2. This is the October 2025 paper. We'll do the Jan 2025 papers as well, okay? I have got the papers. We'll do them soon. Okay, this is a very good question. It's about a standing wave. It's actually an MCQ question. Okay, so I'm going to need you guys to get the answer for this MCQ question. Okay, so for those who are watching the recording, the other thing, you are getting only 30 seconds here. Try to get the answer within 30 seconds. If you have gotten the answer, raise your hands. Okay, I haven't sent the question yet. Hold on. Haven't sent the question yet. So for those who are watching the recording, this is the question I'm sending at 8:16 p.m. Okay, right. 30 seconds. Timer. Come on now. 30 seconds. Okay, so all of you must have received the question. I'm going to give you all 30 seconds only. So in the exam, if you think about it, you are getting actually around 1 minute to do a MCQ. I'm going to give you 30 minutes, 30 seconds, okay? So read the question, start getting the answer. 30-second timer starts now. So once you're done, raise your hands. Okay, actually half the time is gone. Okay, done. Okay, time's up, guys. So how many of you were actually able to get the answer? One. Rumika was able to. Two, three. Four of you were able to get the answer. It's very bad. Right. Let's see. Let's see what happens in this MCQ. So, what's the answer that you got? Rumika, can you send me a message in the sense chat to the chat? What's the answer you have gotten there? Google Meet chat. Yes, that is actually correct. A string vibrates between 2 points. The diagram shows the stationary wave formed on the string when it vibrates with a frequency f. Tension is doubled, frequency of adjusted until the same shape is given. So how do we get the answer here? V equals root T over mu. Frequency is adjusted, tension is doubled. So you should know they haven't said anything about what? The frequency adjusted in the sense the velocity should remain the same, shouldn't it? So from the equation, it should be no. Hold on. Can't take it like that. Right. Who else got B as the answer? Can you raise your hands? Who else got B? Yes. Why B though? Okay, I'm gonna ask questions now. Rumika, tell me why did you get the answer as B?
I rewrote the equation as so V equals F lambda. So then F lambda equals root T over mu.
Okay.
Then if you multiply D by 2, then you have to multiply the whole equation by root 2. So
Uh-huh.
it's root 2 F lambda.
Yes.
Lambda is the same, so then it's root 2.
So they are proportional. Because of that, you can straight away take root 2f. You're actually correct. That is the answer. If you had not understand what Rumika just said, like you couldn't hear, it's like this. V is equal to root T over mu. F lambda. Root T over mu. They say tension was double, no? So can you understand F is directly proportional to root T? So then, if this was 2, this should also be multiplied by root 2. It's very easy. You don't need to think about it in this manner. You can straight away think about it in proportionality. F is proportional to root T. To root 2. Is it clear? So in MCQs, try to get the answer without touching your pen. I mean, you can write a small expression like this. That's fine. However, try to minimize the use of your pen, because if you like using your pen, you'll tend to write equations like this to get the answer for a 1 mark MCQ. So our objective in the MCQ paper, in the 10 MCQs that you are getting in the exam, is to get the maximum amount of marks in the limited period of time. If you can do the MCQs within 8 minutes, okay, within 8 minutes and get 10 out of 10, you'll get a world rank. Okay, right. But actually, you have tried this is quite good as well. 70 marks for this is no. Okay. Anyway, I'm gonna send you 3 MCQs. You have to quickly get the answer like that. Okay. Right. So I'm gonna send you the MCQs. Hold on. 1, 2, 3. This is way too easy. One. Can't I send all the MCQs at once? 2. I can know. Yes. 3. I mean, these MCQs are really easy. Yeah? Okay, 4. And yes, atomic line spectra. 5. Yeah, I might as well send this. So 6. So I'm gonna give you 3 minutes. Okay, I'm gonna give you 3 minutes, guys. I want you all to get these MCQs done. There are 6 MCQs. Okay, so now you should be getting them. And for those who are watching the recordings, these MCQs are the MCQs that I'm sent at 8:23 p.m. Okay, 8:23 p.m. I want you to try and get the answers for those 6 MCQs within 3 minutes. So I'm gonna put a timer. Right, I'm gonna put a timer. I should have put the timer before sending you all the questions, no? So, like our previous questions, once you're done, you must raise your hands, okay? 3 minutes started. Okay, 3 minutes. I've started with the answers. Okay, right. You have got 2 minutes 45 seconds. Try to get the answers. Okay, done? Not done. Sorry. Should be doing. Okay, you guys have got 1.5 minutes. Okay. So once you're done, raise your hands. Huh? I think like 3 minutes is a bit like too overkill. Should I have given you a little bit more time? Hmm. Come on. The timer is going off in like 30 seconds. Uh, you know what, guys? Take your time. Let's finish these questions first of all properly, and raise your hands once you're done. Okay. Rumika, keep your hand raised. Others, just let me know once I'm in class. Okay. Okay. You are still done. Okay, one is finished. Uh, what about you? What about online student Rumika? Rumika, what about you? Are you still doing?
I'm thinking I don't know one question how to do it correct.
Alright, here's the thing. If you don't know how to do a question, you can just leave it. Huh? So you have finished the other questions, but you're not done with current, no? Okay, we'll see. So take your time. Others finish. Actually, while you're doing the questions, just listen. Um, I started this what do you call diet, no? So I'm actually now training with a personal trainer in a gym. So I've gotten like way too fat after I've started tutoring. Anyway, um, so the diet got, how do I say it without so this is being recorded, otherwise there's like a nice word. The diet got like, how do I say it? The diet got paused. I'll just put it like that. The reason is I got sick, no, so I couldn't eat anything. Uh, so I was just eating this noodles and stuff. So it's not really good for your health apparently. Anyway, um, so what you should understand, not what you should understand. So after that, now my trainer called. Okay, so I got permission from him just to eat on our arms giving day. Okay, so he was like, okay, you can eat, but just eat in a controlled manner. Okay, I did exactly the opposite, and I apparently got sick also. No? Now he's furious. I have to go to the gym again on Thursday. Ah, I was doing actually 4 sessions a week with him. The remaining 2 days I was doing cardio. I actually lost like 2.5 kilos in 1 week. It's actually pretty good apparently. Yeah. So anyway, I have started again. I think I might have like added those 2.5 kg. And did you know, guys? Did you know if you want to like lose, if you want to lose or gain 1 kg, not muscle, not fat either. It's like fully weight. Okay. If you want to gain 1 kg of weight or lose 1 kg of weight, you have to either go for a 7,700 joules, not joules, calorie, 7,700 calories surplus or a deficit. That means you have to either lose 7,700 calories from your diet or somehow increase 7,700 calories to your diet in a week, within a week. So let's say you want to gain 2 kilograms within a week, you have to add 15,200 calories to your diet, like more than your body needs. So it depends on your weight, actually, weight and height current. So my body apparently needs 2,600 calories a day for maintenance, but I only take, in my diet I can only take 1,500 calories. It sums after around that. So every single day I'm getting a 700, 900 calorie deficit, and on top of that I'm like burning 100 cal working out, no. So like 1,000 cal deficit every single day. In the first weeks, you lose weight fast because of like majority is water weight, but after that, after like 2 weeks, it kind of like slows down and you start building muscle. So yeah, you get the point. Anyway, we'll see once you guys are writing exam and before A2. So you get like, I give like 3 weeks or 4 weeks holiday, after the exam. Then we'll see my transformation. You'll be able to see it. We'll see. Anyway, I think it's time for me to discuss now, no? Yeah. Okay, the first question that I've sent. Um, It was about this wavelength thing, no? The diagram represents a longitudinal wave. What is the wavelength? So what is the wavelength, guys, actually? Tell me. What is the wavelength? What is meant by wavelength? Can you tell me? Wavelength means distance of one complete oscillation. So here they have drawn this wave in wave fronts. They have drawn this longitudinal wave as wave fronts. So then what should we do here? So you should understand meter dou, yes. You should understand the whole length of, so there are rarefactions and compressions. So the places where they have got compressions, they have like drawn these wavefronts closer together. And then the places where there are rarefactions, they have drawn these waves apart from each other. So raise your hands, those who say the answer is A. Raise your hands, those who say the answer is A. Okay. So Romika, can you tell me why the answer is A?
The length between two compressors are
Yes. Yes. That is the reason I came to the definition of wavelength. I only told one definition for wavelength. There are like two more definitions for wavelength. Not two, actually four more. One is the length between two crests. The other one is length between two troughs. The other one is length between two compressions. And the last one is length between two rarefactions. When saying rarefactions, it should be from the middle of one rarefaction to the middle of another rarefaction, which are like consecutively apart. Okay, right. So the answer is A, therefore. Right. Question number 3. What's the answer here? Raise your hands, those who have gotten the answer as 3. Sorry, as D. My bad, as D. If you have gotten the answer as D, raise your hands. So here, all you have to do is, diagram shows the trace of oscilloscope. One horizontal division represents 5 milliseconds. So what do they say by 5 milliseconds? That's the time period, right? So basically you have to calculate how many of those divisions are there for one complete oscillations. Why? Frequency, as we know, frequency, what's the equation? Frequency is equal to 1 over time period. I'm sorry. Frequency is equal to 1 over time period. So what is time period? Time period means time taken for one complete oscillation. So can you understand, after like reading those two questions, question number 2 and question number 3, they are simply checking your memory. They are simply checking your memory on second lesson waves part. These are basic definitions that we give in class. When we learn theory, we learn about these definitions. They are just checking whether you know these definitions. That's it. So here you can understand there are how many divisions? 3 divisions, no? Sorry. For one complete wavelength, there are 4 divisions. There are 4 divisions. So what's the time period? 4 times 5 milliseconds, no? So what is 5 milliseconds? 4 times 0.005 seconds. That is the time period. So what is F? 1 over 4 times 0.005. I'm sorry. Is it clear? Yes, that is why the answer is D there. Then next question. What's the next question? Question number, let me check, 4. Okay, this is really easy. It's about de Broglie wavelength. Electron has a velocity of this much. So de Broglie wavelength is h over Planck's constant over momentum, right? Mass times velocity. So here they are talking about the mass of an electron. What is the only answer which has mass of the electron in the denominator? What is the only answer which contains mass of the electron in the denominator? B. That's the answer. That's it. I'm not even going to explain it. Okay. It's very easy. Lambda, this is de Broglie wavelength. H over mv. This is what you need to consider. M means mass of the electron. V means velocity of the electron. Okay. Right. Question number next. What's the question that we were doing? Next question is question number 8. So it's about internal resistance, no? Okay. A student connects 5 identical 1.5 volt cells in parallel to form a battery. Okay, I mean, this is actually pretty easy. 5 identical 1.5 volt cells parallel. So these are just EMFs, no? Yes. Each cell has internal resistance 1 ohm. Okay, so can you understand, when you connect resistors, 5 resistors, each 1 ohm parallelly, the the equivalent resistance will be 0.2 ohms. Can you understand that? Just have to use 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. Like, you have to just use that equation that we use for parallel resistors. However, this is not in your syllabus. You must remember this. If we connect EMF, in the sense voltage, batteries, dry cells parallelly, their EMF does not change. Why? We have learned that across 2 points the potential difference remains same. So if you want to change, we need to connect these batteries serially. Therefore, even though we connect 1000 dry cells parallelly, we'll still get what? We'll still get the same voltage of one battery. So the answer is 1.5 and 0.2. Is it clear for everyone? Yes. What about you, Rumika? Rumika, is it clear for you? Like the addition of these resistors and everything? Is it clear or should I do it again?
So when it's in series, we just add it like R1 plus R2.
Yeah, when it is in series, the resistor, we just add it R1 plus R2, likewise we add it. However, if it is parallel, we take 1 over R1, 1 over R2, likewise we take it. Okay, right. Then we have got the atomic line spectra question. So here from n equals 4 to n equals 1, an electron is going to jump. No? The frequency of photon is emitted. Which of the following photon frequencies could not be emitted by this atom? So how do we get the answer for a question like this? Can it be f over 8? It can't be that small, no? And can it be 3f? I don't know. Can it be f over 8? I don't know. I was just saying. Can it be f over? They are asking what could not be. Can it be f over 8? It can't. Can it be 3f? It can, yes. It can be 3f. It can be 3f. That can actually happen. What about f over 4? F over 4 is also possible. That is also possible to happen. What about f over 2? F over 2, yes. If f over 4 is possible, f over 2 is also possible. Yes. So how do we actually take the answer here? We can't just randomly connect these things, no man. Like f over 2, f over 8. We've got 3f again. So actually tell me, first of all, what happens here, guys? What happens here? Initially, so I'm going to do like a small explanation as well about what happens in this question. Atomic line spectra question. Initially what happens is, there is a electron. It gets excited. It's going to jump to higher energy levels because of that excitation. So what's going to happen? We are getting an absorption spectrum then. What is this absorption spectrum? Can you remember there's a spectrum rainbow colored with black color lines? That is the absorption spectrum. Why do we have black color lines? Because at the frequencies those lines represent, the wavelengths those lines represent, at that those exact points, that specific energy has been absorbed by that electron when jumping from one energy level to another. Okay. So what is this emission spectrum then? That is the scenario they have asked in this question. So basically, once an excited electron jumps to a higher state, what happens? It's going to get de-excited at some point. It's similar to like even the electrons, they are similar to us as well. So for example, imagine you bought a new phone or a new gadget or something that you like a week you will have a really good care into it. You'll put a lot of care, you'll like wipe it and everything. If it is a phone, you'll clean it almost daily, and then like you'll do a lot of stuff. You won't even keep it on ground, you'll always put it in your pocket, you'll put a protective cover. But after a year, අර පාරේ බල්ලෙක් දැක්කත් බල්ලටත් ගහන්නේ ෆෝන් එකේ, right? It'll be like that. So then similarly, electrons also behave like that. They get de-excited. They lose interest. So what do? They jump back to their previous state. Generalize වෙනවා යාලත්. So then what happens? Then only we get an emission spectrum. That is the spectrum where you get this black line and these colored lines are there. Those colored lines mean the energy emitted by the electron when jumping from a higher to lower energy level. In this diagram, the energy levels shown are n equals 4 to 1, n equals 3 to 1, 2 to 1. Yes. And 1, n equals 1 is the ground state as they are represented. So, methanol in the left hand side, okay, they have said energy in electron volts. -1, -2, -4, -5. What does that mean? That means at n equals 4, it's going to have energy of -1 electron volts. Is it clear? At n equals 1, it's going to have an energy of -5 electron volts. So what if an electron jumps from n equals 4 to n equals 1? When an electron jumps from n equals 4 to n equals 1, we have to take the difference. So at n equals 4, it's going to have a energy E1 minus E2. Okay, that's the difference. So basically -1 minus -5, no? What will it be? 4 plus 4 electron volts. Is it clear? How do we calculate this energy of electron volts? We take it as HF. We know that H is a constant. We know that H is a constant. Then can you understand for 4 electron volts, this F is no. Yeah, HF equals 4 electron volts. In our answers that they have given, as F over 8. They have given the frequency. So we should kind of like isolate the frequency. Anyway, the HF product is 4 electron volts. Okay. HF products they have said to be 4 electron volts. Then that's from 4 to 1. 4 to 2 we don't need. 4 to 3 also we don't need. What about 3 to 1? Sorry, let's take 2 to 1. So now this was for 4 to 1. What about 2 to 1, guys? What about 2 to 1? At 2, tell me what's the energy they have said. -4. Minus -5. we've got 1 electron volt. Ne? Here we've got 1 electron volt. So can you understand if HF, this is for 2 to 1, this is also equal to HF. Then let's take 3 to 1, sorry, 4 to 2, 4 to 2, 4 to 2. I'm going to write it here, 4 to 2. 4 to 2, HF is equal to, what is 4? Again, minus 1. Minus 1 minus 4. So we get 3 electron volts. That is equal to HF again. So these frequencies are different. Huh? This I'm going to take it as F1. Let's take this as F2. Take this as F3. I want to equate everyone to F1. This common F. I'll just take it as F2, F3. This F. How can I equate? Can you understand? This F2 will be equal to 3 over 4F. 3 over 4F. Why? For 4 electron volts, divide by 4 multiplied by 3, we get 3 electron volts. Is it clear? In terms of F, this will be 3 over 4F. In terms of F, this will be how much? F3 will be 1 over 4F. Is it clear? Then can you understand, okay, this 1 over 4, 3 over 4, 1 over 2 and 3F, even 3F, those values are possible. Is it clear to you? Can you understand? We can't divide F by 8. There's no such expression for 1 over 8. Make n කියලා තේරෙනවද? If you write it like this, we won't get 1 over 8 F. Is it clear? So that should be the answer there. Just raise your hands if you understood this method the way I took it. So in your theory, actually, they don't explain it this much. When teaching theory, what teachers do is, as well as me, math karanne when මෙහෙම delta E equals E1 minus E2 කියලා, I'll just give it to you and then show that these energy levels have values. So when this drops, E1 minus E2. Just raise your hands if you understood this. Rumika, did you understood this? Yes or no? Can't hear. You understood. What did you understood?
How much energy is being given out by the phone?
Yes. Yes. So here, yeah, you are correct. So basically here the answer is A. Did you got that correct? Yes. Okay. Great. Right. What about others? Did you all understand this as well? Just raise hands who got answer as A for this question. Okay. This is basically like a guessing game. Huh? You have to like guess in this manner. I mean, most of the MCQs, if you think about it really, it's more like a guess. Because see, any of these 4 answers, A, B, C, D, could be true. You should know the exact method to get the answer. I mean, as long as you know the method, you'll get the answer. But if not, what if you don't know the method? You have to guess and write the answer. So when guessing also, I think I've taught you the elimination method in the previous classes, right guys? So you have to use that method and guess the most probable answer. Find the most probable answer and write it. Okay. Now, coming to our last question. Question number 10. Dear card holder, your okay. Right. The diagram shows there's a 4 ohm resistor and then an internal resistor, right? Yes. Which of the expression gives the potential difference V across internal resistance of the cell? Okay. So I'll just draw a diagram and explain it. So basically here, this is a dry cell, guys. This is a dry cell. And then there's a resistor here. So actually, what is the battery then? This is only the dry cell. Huh? Battery is this. This is the battery. So you got this pointy part. This is positive charge and this end is negative charge. Is it clear? That is the battery. That is what you call the battery. That is what we see as the battery. There's always an internal resistance inside the battery. That is the reason the battery gets heated up. Then there's a 4 ohm resistor separately. Now tell me, if the voltage was V, no, they have basically told that the EMF is 12. No, they have told that the EMF is 12. So can you understand, if the EMF is 12, can you understand here what should happen here? This is 12. 12 volts are acting throughout the circuit. You are supposed to find how many volts will be acting across this internal resistor if we were to attach a voltmeter across it. So since these two resistors, so what I want you to do now is, in a question like this, forget about the dry cell. Not the dry cell. Forget about the battery. Yeah? This is the dry cell. Don't jumble it. This is the battery. Don't get confused. I'm going to erase the battery now. Forget about the battery. Think of only dry cell and the resistors. So basically, now since we have forgotten about the battery, there's no such thing called internal resistance. It's just normal resistor. Two resistors connected serially. Tell me, but so there are two ways to get the answer here. Okay, there are two ways in the MCQ. Since this is MCQ paper, they are asking for the short method. That's the reason. So usually, if this was essay question, you will take answer like this. If you don't know the short method, you will take answer like this. You will probably calculate the total voltage, which is 12 volts, and use V equals IR. We know R is 6 ohms, right? Since these two are connected serially, we can just add them. So 12 divided by 6 is equal to I. We will find I as 2 amperes. And then what is V across 2 ohms? Again use V equals IR. Multiply 2 amperes by 2. You will get 4 volts. 4 volts are acting. So if you really don't know how to get the answer in the short method, you can find the answer as 4 volts. This voltmeter is showing. And then out of the above 4 answers given, you can find the answer that says that says 4 volts. So that answer is A. In this question, that answer is A. The other method is, you have to understand, voltage is a ratio. We are measuring the potential difference. For a higher resistance, the potential difference across will be higher. So first of all, you have to calculate the total resistance of the circuit. So if I want to find the voltage across here, if I take it as V, V will be equal to EMF multiplied by 2. The resistor we are taking the voltage across divided by the total resistance, 2 over 4. That is how you should get the answer. So in Kirchhoff's voltages rule, we learn this method under potential divider. So there's this equation. So it's like this. Imagine if this is a dry cell and there are two resistors, R1, R2. This is the theory part, okay, related to this. Let's say you are supposed to find the voltage across R1, V across R1. So then V is the voltage across R1, okay. This is EMF. I'm going to take this as V1. V1 is the voltage across R1. V is the main voltage. V1 will be equal to V times R1 over R1 plus R2. Is it clear for you, Romika? Since you are the one who doesn't know this electricity part. Is this part clear for you? It is, right? So this is the theory part related to that. So what if, just in case, what if you are supposed to find what is R2? What if you are supposed to find the voltage across R2? I'm going to draw for that and write that as well. Let's look at the board. Let's say you are supposed to find the voltage across R2. So then this was the circuit we drew now. This is V. We've got R2 here and now R1 here. You are supposed to find voltage V2 across R2, okay? So then V2 will be equal to total EMF V times R2 over R1 plus R2. Is it clear? It's like a ratio we are building. Okay? It's like that. So we are basically saying out of the main EMF, the main power given to the cell, this much of a amount is acting across R2. That will solely depend on the resistance of R2. If R1 has a greater resistance than R2, more voltage will be acting across R2. If R2 has a greater resistance than R1, more voltage will be acting across it as well. Okay, is that clear? Is that clear to you all? Yes, Neither. Yes. So, Romika, I hope it's clear to you as well. Yes. So then, that is it for today, guys. Okay. So we have discussed a lot of questions randomly from all the papers that I have been able to get my hands on. So next week, actually, we'll discuss those papers that I have said in the group. 2021 May June, Unit 1, I think, and 2025 May June, Unit 2. No, those are the papers, right? No, 2021 May June, Unit 2, and 2025 May June, Unit 1. So I'm just gonna pin it. What's the pinning part? 7 days. Yes, I'm just gonna pin it in our group for 7 days. And yeah, that is it for today. That is it for today. We'll be discussing those papers next week. Okay. So make sure to get those papers done. If you have done those papers, just check those papers again so we can reduce the time in which we are using to discuss them and quickly go to those papers. And also, I will let you know next week on a date we can do a revision for Unit 2 actually. Okay, I'm just waiting till these big matches are over. No, Rohito is there in 12, 13, 14. No, yo, I have to also go, man. I don't like to go. Just bought a ticket in our school tent. Come on, I'll just give it to someone. Because like we are playing no ne. Ano ne to yes. Balam. If you are playing a reserve ne inna ge hai. Alright, so if you are playing, just let me know. I'll just come. I have anyway got the tickets for escorts. Balam. No, escorts is like a new tent, man. For those who left school after 2017. Yeah. Anyway, so Romika, you guys don't have big matches, no? You are from Gateway, no? But actually, I think you can come. Don't come. Study, stay at home and study. Anyway, that is it for today. So maybe not next week. Then next week, behane. Then week after, I'll tell on a date that we are gonna be doing revision for Unit 2. We'll just take like 4 days and do the revision quickly. Unit 3, don't worry about it at all, guys. Okay. Unit 3, it's the easiest topic ever. Just trust me on it. Like you won't ever get a easy topic than Unit 3 and Unit 6. At least even like 1 month before the exam. Not 1 month. I've had students who have just like gotten to know all the theory of Unit 3 just the day before the exam, and they were still able to get a B pass. This was last year, May, June, I think. Yes. So yeah. Yes, that is it for today. We'll meet back again next week with those papers. Okay. So goodbye. Have a beautiful day. Okay. Goodbye. You can leave the class. Okay, Romika. Goodbye. Good night.